Hi guys. Now in this video I have already solved the demand function, and you can see it's negative 100p plus 100 for this problem. You can sell 50 bagels for 50 cents each, but if you charge 75 cents, you'll sell 25. The cheapest supplier has 35 bagels for 15 cents each, but the next cheapest has 65 for $11 total. So we've done part A, which is here, and we've done part B, which is right over here. So this is part B right here. Oops. Oh, come on. There. Okay, so we'll put a B next to that guy. Be good. Up. Up. B. So that's part B. Now we've got a function so we've got two functions. Demand tells us is a negative slope. So it looks, oops, come on, do a negative slope here. Stop taking my ink away. Okay, so you have a negative slope for demand. Right? It looks vaguely like this. And then we have supply, which is a positive slope. So supply I'll draw in red. It's got an even higher positive slope. It looks like that. So the idea is if supply, so the idea is that okay, if you're charging around this area, if your prices are around this area, now what's going to happen is you can only sell this much but this is how much you could buy for that same price. What's going to happen is some other guys, so let's say you're only buying this much, right, over there. You only want to buy as much as you're going to sell. So that area would be your profit. But some other guy's going to come along and buy this much, so he's going to have to pay some more to buy. But he's going to charge that much. So he's going to end up charging less than you and selling more. So he's going to sell a lot more. Somewhat more anyway than you, and he's going to charge now. And he's not going to make as much money, but maybe he'll be happy with that, right? And the idea is people will come along and keep doing that. Now, if you decide to sell this much, to charge that much, okay, so that's a low price. You're going to want to sell that much, but you're not going to be able to afford to. You're only going to be able to afford to charge to buy this much. So this part area is going to be a shortage. People are going to want to buy more than you can afford. So someone will come along and say, okay, there are people who want bagels. I'll make a little more money, and it took my ink away again, by charging this much. Come on, give me money. Go there. Give me ink. And then I'll be able to afford to buy that much bagels. So there's a lot of pressure right to this go to intersection point. And that's what we're doing. That's what equilibrium is about. It's the place, if they try to charge more, then there's pressure, and someone else comes along and charges less, and you lose business. And if you and if you try to charge too little, then you get overflowed with customers, and you have problems and someone steals your customers away. And so the sweet spot is that intersection. So what we're going to do is now to solve a linear intersection, to find the equilibrium price and quantity, to solve a linear intersection is solving the linear intersection. So I'm going to take these two functions. I'm going to take negative 100p plus 100 and set it equal. That's the demand function, right? It's the place where it's the equilibrium price. Let me write that down. Is the price where the total demand and total supply is equal. So this is the price that in a purely capitalist system you should end up with. Now, systems aren't always purely capitalist, right? Prices can be kept high. For example, if someone undersells you and starts stealing your customers away, one way to react is to say, oh my, I must lower my prices. But another way to react is to call your cousin Arnie. Hey, Arnie, I hear you have some big guys with large guns. Can you send them over to this guy? He's trying to undercut me. And so criminal behavior can artificially raise prices. And it's not criminal, of course, if the government does it. So the government can just declare prices. Similarly, the government can decide prices are too high. You want to charge more than that? Well, large people with guns, this time in uniform, show up and say, don't do that. And you can't do that. So you can but these are violations of capitalism. In a pure capitalist system, you get to the equilibrium price. So let's see. So we get, once again, let me write that down. The demand function, D of P, will equal the supply function, S of P, in the equilibrium. Okay, and that P is the equilibrium price. Now, so we're going to get 100p. No, that's not right. Negative 100p plus 100 is going to equal, yes, I know, ignore that, 5200p minus 745. Now, we just solve for p. So, I'm going to add 100p to both sides. Because when in doubt, I get rid of negative numbers. So we'll get 100p to both sides. We'll get 100 equals 5300p minus 745. 45. Okay, now I'll add 745 to both sides. And I'm going to get 845 is equal to 5300p. Now to get the actual price, Okay, I'm going to divide both sides by 5,300. And that'll give me a value for P, 845. Now, I don't know, I can't do this one in my head. Minus 5,300, divided by 5,300 is going to give me about 16 cents a bagel. And that's going to be P, which is the equilibrium price. So that tells me, and that's the answer to part C. What is the equilibrium price? And to get the equilibrium quantity, part D, what we're going to do is plug this in to one of my functions, because all my functions go from price to quantity, right? Quantity is a function of price. So I'm going to take negative 100 times 0.1594. Well, let's just round that to cents. 16 cents. Okay, and I'm going to add 100, and that's going to tell me that I'm going to sell 84 bagels. And if I got this right, that would be the equilibrium quantity. Now notice there's a little round off, so that's going to cause a little problem with the check, which is I'm going to do now. Now, if I got this right, the supply function, 5200p minus 745, S of P, should give me the same thing. Now, I rounded it off, so it won't give me exactly the same thing, but maybe if it's close, I'll take it. So I'm going to take 16 cents again, and we'll subtract 745. And I get 87. So you say, maybe that's not close enough. So let's add another digit, 1.59. 1.59. Now what's going to happen here is I'm going to get 84 instead of 85. And what's going to happen here, this is going to give me 81, 82. So it's getting closer. Instead of 83 and 87, it's significantly closer. Now, if I add another digit, you see, it'll get even closer. So if I do that, it's still about 84, but and if I do that, now it gets really close. So this tells me that these two are the same. So if it doesn't check when you round less, see if that checks. And give me that. Make a nice big check. And so that is equilibrium. And now with some luck, I'll be able to